friction, wear, lubrication. These three rule every engine I open. But smooth metal alone isn't the answer. The surprise is simple. A perfect mirror finish can hurt you. Engine parts need a careful balance, not just a perfect polish. Think of running shoes. You want grip for speed, but that same friction also wears the tread. Engines live in that same push and pull. Tribology is the science of friction, lubrication, and wear. That's the language I use when I test parts and oils. Without the right lube film, sliding metal can seize and even weld itself together. With the right film, parts glide, heat drops, and life goes up. In this conversation, I sat down with Dr. Peter Lee from Southwest Research Institute, Dr. Don Cohen from Michigan Metrology, and Dr. Mark Malberg. We dug into how surface texture, coatings, and oil chemistry team up to protect the hard stuff we care about. Here's the plan today. Surfaces, coatings, oil additives, lab tests versus engines, then real-world oil choice. I'll keep it clear and practical, step by step. Did you know tribology was even a word? I love showing how this science saves real parts and real money. You're watching Recall Roadmap with Morgan. Let's start where contact begins, at the surface, because the truth about smooth is not what most folks expect. Engines love shine, right? It looks fast on a workbench. However, too much polish can strip away the oil pockets that keep parts safe. Here's the twist I show customers all the time. The best finish has flat tops but tiny valleys. Those shallow grooves hold oil and feed it back into the contact as parts slide. This is why cylinder bores are crosshatched and then plateau honed. After honing, the sharp peaks get knocked down and the valleys stay. Many shops shoot for about a 45-degree crosshatch. That texture keeps a reservoir of oil on the wall. Studies show the thickest oil film happens on surfaces with many shallow cavities and very few peaks. In plain words, the oil has somewhere to live, so the metal doesn't have to touch. I've seen it under a microscope with surface maps, the kind Dr. Don Cohen's team uses. When the peaks are controlled, the boundary contact area can drop by 30 to 50%. Less hard contact means less scuff, less heat, and longer life. It's like tire treads. Grooves make grip and move water. In engines, valleys feed oil and move heat. Now that we've got the surface working for us, do all engines thrive on the same oil? Not quite. That's our next puzzle piece. One jug for every job sounds neat and tidy, yet not all parts agree. Bearings want stable film and flow. Flat tappet cams want hard anti-wear. Gears want extreme pressure strength. A single oil has to juggle all of it, and something gives. Here's the reality. In modern specs, car makers split needs on purpose. For example, gasoline and diesel engines often get different approvals, like VW 508 and 509. Why? Because the mix of parts, soot, heat, and emissions gear are not the same. Inside the bottle, the star anti-wear agent is ZDDP. As one tribology lead put it, to their knowledge, an anti-wear additive on par with ZDDP has not yet been found. Another expert adds that ZDDPs are better and cheaper than any alternative for the jobs they perform. That is why you still see zinc and phosphorus in so many blends. But there is a trade. More ZDDP can slightly raise friction and can stress catalytic converters. Typical engine oils target around 0.1 to 0.2% zinc by weight to build a protective film without going overboard. If that's the hero, what does it actually do? Let's open the chemistry. Oil is not just oil. It's a base stock plus a smart chemistry kit. Zinc, phosphorus, boron, and molybdenum are tiny in dose, but huge in effect. ZDDP, short for zinc dialkyl dithiaphosphate, is the classic. It was first patented back in 1941, and 8 decades later it still anchors many formulas. Why? Under pressure and heat, it builds a fast, glassy tribofilm on the metal. That film takes the hit, so your cam lobe does not. Experts describe ZDDP as both a powerful anti-wear shield and a strong antioxidant. That means it helps stop scuff and also fights oil breakdown. Some even note it can help guard against knock by keeping deposits in check. Then you have friction modifiers like molybdenum dithiocarbamate. Mo chemistry can make sliding feel more like rolling at the contact, which cuts drag and heat. Add borates or other boosters and you tune the feel further. But every change moves another needle. More anti-wear can mean more ash for a catalyst. More friction modifier can alter clutch feel in a shared sump system. This balance is why big datasets and years of testing steer real blends. If this is helping, tap subscribe and share it with a friend. Next up, can lab tests capture all this? Labs use clever rigs. Spinning balls, loaded gears, sliding pins. These tests are fast and repeatable, and they do reveal trends. But a lab test is not the whole story. Real engines bring heat spikes, dirt, fuel dilution, and start-stop shocks that many rigs skip. Take a common 4-ball test. It pinches oil between steel spheres and reports a wear scar size. Helpful, yes, but life is not a steady pinch. Even researchers note that wear data can show varying repeatability and reproducibility. 2 runs, same setup, can land a different number. If that is true on a bench, imagine the spread when you throw in soot, coolant mist, or cold starts. This is why many teams rely on engine dynamometer sequences and actual teardowns to cross-check the bench wins. In my own work, that kind of proof changes minds. Dr. Peter Lee's world at Southwest Research Institute is full of those real engine trials that make or break an oil. So use bench data as a guide, not gospel. Look for oils that win in more than one test and also show clean parts in engine checks. Lab limits are real. Now, let's face the nasty stuff engines see every day. In a perfect slide, oil carries the load and everyone smiles. In real life, tiny villains sneak in. Even the best oil cannot stop everything. Grit, soot, water, fuel, and acids poke holes in the film and let metal touch metal. One grain of sand under a bearing can start a scratch that grows into a groove. I have torn down engines where a small coolant leak turned bearings dull and rough in a short time. Fuel wash thins the oil and can push wear to 4 times normal. Trace metal shavings and hard soot act like sandpaper and can boost the wear rate 3 to 5 times. Rapid speed swings can even make cavitation under high-load bearings. Those vapor bubbles collapse and pit the surface. Now debris has a place to sit, and the cycle speeds up. Coatings help a lot here. Nitriding, PVD, and DLC can resist scuff and carry more load. But even great coatings lose to dirty oil. The filter is your quiet hero. A fresh quality filter and on-time oil changes remove well over 90% of wear particles. We know the traps. Now let's turn all this into smart oil choices and simple habits you can use. Here's the simple playbook I use with customers. Start with the grade and the approval your maker calls for. That label matters. If it says your engine needs a certain spec, like a maker's own long-life code, use it. Those specs bundle many tests, not just one. Next, match oil behavior to your parts. Older flat tappet cams or high spring builds? Favor blends known for strong boundary films, often with higher zinc and phosphorus. New turbo direct injection engines? You need control for low-speed pre-ignition and deposits, so pick oils that pass the modern sequence tests for that. If you tow or run hot, look for endurance and oxidation performance, not only low friction claims. Trust proof you can see. Engine dyno results and teardown photos beat a single bench score. Trade journals and tribology groups say the enormous data sets behind engine oils are what anchor current and future blends. I agree. That big picture view keeps you safe. Finally, keep it clean. Stick to oil and filter intervals, fix leaks fast, and watch fuel dilution. Surfaces, coatings, and chemistry only shine when the oil stays healthy. With that, your engine is already ahead of wear. Let's wrap this up clean and quick. We just peeled back how friction, wear, and lubrication really work together. Smooth is not always best. Tiny valleys hold oil. Coatings buy margin. Additives like ZDDP build a shield when the squeeze gets real. Bench tests teach us a lot, but engines decide the truth. And one oil will always be a balancing act, not magic. Here's my bottom line. Think like a tribologist. Match the surface finish, coating, and oil to the job. Trust results from engines, not just a single bench chart. Keep the oil clean so the chemistry can do its work. You're watching Recall Roadmap with Morgan, and I'm grateful you spent this time with me. If this helped you see oil in a new way, please subscribe, like, and share. It keeps this work going, and it helps more drivers protect their engines. Thanks for watching. Last thought for you today. Would you trust a bench test or a real engine teardown to choose your oil? Tell me why, and I'll see you in the comments.